Hey guys, back for chapter 3, lesson C, part 2, right triangle trig. Today we're going to cover those topics that I mentioned in the last lesson that we weren't going to get to. Evaluating trig functions involving quadrantals, as well as using reference triangles to evaluate these trig functions of any angle. So let's go ahead and get started. Alright, so let's start first with the idea of a reference angle. A reference angle, let theta be an angle in standard position. Its reference angle is the acute angle formed by the terminal side of theta and the closest, I should have the word closest here, the nearest horizontal axis. So for example, if I've got standard position, rotation, terminal side, our reference angle would be this blue angle right here. Okay, if I have standard position, angle, terminal side, this blue angle here would be our reference angle. Let's do another one. If I have standard position, angle of rotation, terminal side, this blue angle right here would be our angle. It is the acute angle, or the angle of rotation from the terminal side to the nearest horizontal axis. So if you think about it, what you're going to do is if an angle falls in quadrant 1, that's cool. That's easy. That is its angle. If an angle falls in quadrant 4, okay, it's going to be the absolute value of that angle. So for example, the example I have here, let's say this is negative 45 degrees. The reference angle would just be positive 45 degrees. Okay, if an angle falls in quadrant 2, I'm going to take 180 minus the angle I was given. And if the angle falls in quadrant 3, I'm going to take the angle minus 180. Okay, so let's look at a couple of examples. In part 1 here, it says theta equals 300. Well, 300 falls in quadrant 4. Now, okay, I guess there's two cases. One case is take the absolute value, and the other case is 360 minus theta. Now, anytime you do get a negative angle, or you have a negative angle, you're going to have to take its absolute value first in order to work with that. So we'll see that in problem number 3 here in a second. So if I have an angle of 300 degrees, its reference angle, I'm going to call it theta ref, is going to be 360 minus 300, which would be 60 degrees. Okay, in part 2, 220 falls in quadrant 3. Okay, and in quadrant 3, what I get is the angle, so theta ref would be the angle 220 minus 180, which is going to be 40. Okay, in number 3, we also fall in quadrant 3. Therefore, let's talk about what we would do here. Here's quadrant 3. We rotate 135 degrees. In actuality, we're rotating negative 135 degrees. Okay, so what can we do? What we can do is find a coterminal angle to negative 135, which would be a positive 225, which would be this angle of rotation. And now we're going to take 225 to find theta ref. Put that in a different color. To find our reference angle, this angle, we take 225 minus 180, which is 45. Okay, let's look at number 4. Theta equals 1.2 radians. That actually falls in quadrant 1. The reason I know that is because the quadrantal here is pi over 2 angles, or radians, excuse me, which is approximately equal to 1.5 radians. It's a little more than that, but that'll at least give you an idea. Therefore, our reference angle, theta ref, is 1.2 radians. Okay, 7 pi over 6. 7 pi over 6 is just past pi. That's into quadrant 3. So to find theta ref, I'm going to take 7 pi over 6 minus pi. So instead of minus 180, I'm going to subtract pi, which will give me a reference angle of pi over 6. Okay, so what is the reference angle used for? Well, it's used for situations like the following. If you go outside of quadrant 1, it can be more difficult to figure out the sine, cosine, tangent, all the good stuff involving right triangle trig, because we're typically used to the measurements we'd see in quadrant 1. So sine of 5 pi over 6, well, the reference angle for 5 pi over 6, right, since it falls in quadrant 2, right, here's 5 pi over 6. Its reference angle right here in blue is pi over 6. So I know I'm working with pi over 6. Now, if you've memorized the unit circle to a point where you don't even need to sketch this out, then you're going to have absolutely no problem. Because if this is pi over 6, I'd have a negative root 3 over 2, and I'd have a 1/2. And of course, our hypotenuse in the unit circle would be 1. Therefore, the sine of 5 pi over 6 would be the y value, or the vertical component of that triangle, so I would get 1/2. So where does the reference angle come into play? It just comes into play with regards to writing out the side ratios. Okay, cosine of 11 pi over 3. All right, so where does 11 pi over 3 land on the unit circle? Well, I'm going to find a coterminal angle. Okay, let's see what quadrant this ends up in. So I'm going to subtract 2 pi, and 2 pi is equal to 6 pi over 3. So if I subtract 2 pi, or 6 pi over 3, a coterminal side would be equivalent, or a coterminal angle would be 5 pi over 3. And 5 pi over 3 is located in quadrant 4. Here's 5 pi over 3. Its reference angle would be this angle. So in order to find that angle, I take 2 pi minus 5 pi over 3. So 6 pi over 3 minus 5 pi over 3 gives me my reference angle of pi over 3. Therefore, when I consider this triangle, this angle right here, my reference angle, is pi over 3. That makes this side length a half, this side length a negative root 3 over 2, because we're in quadrant 4. Hypotenuse is 1, so the cosine would be 1/2. Okay, let's look at cosecant of negative 5 pi over 4. First, what we should do is find a positive coterminal angle to negative 5 pi over 4. So if I add pi, so let's take negative 5 pi over 4, and let's add, 2 pi, so that would be 8 pi over 4. Now notice what I did there. This is equivalent to 2 pi. If I add those two together, I get 3 pi over 4. So this is asking for the cosecant of 3 pi over 4, which is equivalent to 1 over the sine of 3 pi over 4. So let's sketch 3 pi over 4. Happens in quadrant 2. Here it is. Oops, that's 3 pi over 4. So my reference angle is going to be pi over 4. So this triangle, if I want let's first write out the side lengths. This will be 1 over root 2, negative 1 over root 2, positive 1 over root 2, and 1. So the sine of 3 pi over 4 is 1 over root 2. Therefore, the cosecant of 3 pi over 4 is equal to root 2 over 1. And since 3 pi over 4 and negative 5 pi over 4 are coterminal, we get an answer of square root of 2. Okay, cotangent of 7 pi over 6. You should start to become more and more comfortable the more we talk about this. 7 pi over 6 is in quadrant 3. Our reference angle right here will be pi over 6. our triangle will look like such. And therefore we will get a value of -1/2 and -√3/2. And of course that's a 1. The cotangent is 7 pi over 6 is equal to the reciprocal of the tangent of 7 pi over 6. The tangent in this case is a -1/2 over a √3/2. Got a lot going on there. That's going to be equivalent to 1 over, you'll see that the 2's reduce here. Those negatives will negate each other, and we'll get 1 over √3. That's equivalent to √3. Therefore, the cotangent of 7 pi over 6 is √3. Okay, a couple more here. Tangent 5 pi over 2. Well, where is 5 pi over 2? That's past 2 pi, right? So I'm going to find a coterminal angle by subtracting pi to bring it back within that first revolution around the circle. Subtracting 2 pi gives me pi over 2. So I'm able to then say that 5 pi over 2 is coterminal with pi over 2, which there will be no reference triangle here, or reference angle. Because we land on a quadrantal, it won't matter. So this point here is the point 0, 1. So the tangent of 5 pi over 2 is going to be equal to the y value over the x value. Remember, y over x for tangent, which will be 1 over 0, which does not exist. Okay? All right, secant of 10 pi over 6. Well, let me reduce 10 pi over 6. If I divide both of those by 2, I get a 5 pi over 3. And we've seen this angle already. This angle is going to, oh, that was bad. This angle is going to end up in quadrant 4, right about here. Okay, terminal side. Reference angle will end up being pi over 3. So as I sketch my triangle, I've got an angle of pi over 3. I've got a hypotenuse of 1. That's going to make this angle right here 1/2, or side length 1/2, and a -√3/2. So the secant is equal to 1 over the cosine of what I'll call a reduced version, 5 pi over 3. Cosine in this case is 1/2, so this will be equal to 1 over 1/2, which is equivalent to 2. So the secant of 10 pi over 6 is equal to 2. All right, guys, I got one more slide here. That was a bit of a hefty slide, took a lot of explaining, but I think the last slide will go much quicker. Okay, so finding the 6 trig functions for any angle, really what you want to do, and there's a few different scenarios that you'll experience, but you want to make sure that you are comfortable with the 6 trig functions. Okay, and sometimes it's going to be convenient, and you're going to get angle measures or side lengths that are special right triangle side lengths and measures, and other times you won't. But keep in mind these values, right? Keep in mind that the sine is always the y over the hypotenuse. R is the hypotenuse, right? Or the tangent is y over x, or the cosine is x over the hypotenuse, and etc., right? And then all the reciprocal functions. I memorize, personally, I go with sine, cosine, and tangent, and then I just adjust and reciprocate to find the others. Okay? Now, something important to consider is that in quadrant 1, the following functions are positive. Same in 2, same in 3. Well, not same, but similar in 2, 3, and 4 as well. One of the acronyms that we've liked to use in the past is ASTC. And all that means is that the angles that are, or the functions that are positive in quadrant 1 are all of them. In quadrant 2, only the sine function is positive. In quadrant 3, tangent is positive. And in quadrant 4, cosine is the only positive function. We like to call that all students take calculus, right? All students take calculus. Just a nice way to remember that. Okay, so let's get into an example. Example 1 says let negative 3, 4 be a point on the terminal side of an angle in standard position. Find the 6 trig functions of theta. Okay, so negative 3 over left 1, 2, 3, up 1, 2, 3, 4. Okay, so here's the point, negative 3, 4. And it's on the terminal side of an angle in standard position. Find the 6 trig functions of theta. Okay, so we're going to call this our reference angle theta, and we're going to create a triangle. That's what we're doing. So this length here would be negative 3, this length would be 4, and our hypotenuse would be 5. So from there, you can write out your 6 trig functions based on the information that was given. So the sine would be 4/5, cosine would be negative 3/5, tangent would be negative 4/3. Okay, I'm not going to write these out, but the cosecant, secant, and cotangent would follow suit using the reciprocal values. Let's look at number 2. Given that the sine of theta is negative 2/3 and tangent is less than 0, find cosine and cotangent of theta. So where would the sine be negative? That would be where the y values are negative. So that'd be in either quadrant 3 or quadrant 4. But I do know that the tangent is negative as well. So if I look at all students take calculus, the sine would be negative in these two quadrants, but the tangent is negative in that quadrant. So I've got an overlap here in quadrant 4. So I'm going to draw this angle in quadrant 4. Okay, so the sine is negative 2/3. Okay, here's my reference angle, theta. So the sine opposite over hypotenuse. Okay, if I want to know the cosine, then I need to know this x value. So what I can do, Pythagorean Theorem tells me that negative 2 squared plus x squared is equal to 3 squared. So that means 4 plus x squared is equal to 9. So that means x squared is equal to 5, telling me that x is equal to the square root of 5. And now I can find the cosine and the cotangent. So the cosine is adjacent over hypotenuse, which would be root 5 over 3. The cotangent is going to be the reciprocal of tangent. Tangent of theta would be opposite over adjacent. Therefore, cotangent would be opposite or adjacent over opposite. I'll just bring that negative out in front. So there you have those two values. All right, a different way of looking at a very similar problem. Not as much of a thinker because it tells you Q4, right? Quadrant 4. Let theta be an angle in quadrant 4 such that the cosine is 1/5. Okay, so we stayed in quadrant 4, kind of sad. We didn't do a whole lot of getting outside the box, but the cosine is 1/5, right? Adjacent and hypotenuse. Okay, find the sine and the cotangent of theta. Well, I got to use Pythagorean Theorem. I'm going to call this value y is equal to 5 squared. So that's y squared plus 1 is equal to 25. So y squared is equal to 24. So y is equal to root 24. You can leave it like that, or you can simplify the radical, making it 2 root 6. I'll go the crazy way. Call that 2 root 6. Here's theta. Let's find the sine of theta and the cotangent of theta. So the sine of theta would be opposite over hypotenuse, opposite and hypotenuse. Cotangent will be the reciprocal of tangent. I always just find it just to be safe. Tangent is 2 root 6 over 1. Therefore, cotangent would be 1 over 2 root 6. There you have it, guys. That's some good trig work using right triangle trig and reference angles to find any angle, not just an acute angle in quadrant 1. All right, hope that went well. Let me know if you got questions. I will see you in the next video. Have a great day.